So today we are going to see the emissivity measurement apparatus. So already we had seen the introduction to radiation. So and what is the need for to calculate the emissivity for any surface. So coming to the apparatus. So here you can see this is the enclosure. This are two plates. So one is coated with black enamel paint, and we are going to treat this as a black body. And this is the test plate. So we are going to calculate the emissivity of this test plate with respect to this, or we are going to take the reference of this black body. So this is kept in an enclosure to avoid the convection heat losses. So now here you can see this is the temperature indicator. So now coming to the procedure. So first we are going to supply power to first plate, and then we are going to supply the same power to the test plate, right? So we are going to supply, assume 60 watts we are going to supply to the black plate, as well as 60 watts power to the test plate. So see how we are going to set that power values. So now we are going to switch on the apparatus. So here you can see this is the voltmeter reading, and this is the ammeter reading, and this is the temperature indicator. So now here you can see this is the adjustment to increase the voltage as well as current for first plate, and this is for the second plate. So first we are going to supply power to the first plate. So we are going to keep this in first position. So this knob in first position indicates we are going to supply heat or power to the first plate, nothing but black plate. So adjust the value to 120 volts, as well as ammeter reading is 0.53. I think this gives us 66 watts, around 66 watts. So the same power we are going to give to the second test plate. So now we are going to rotate this to the second position. Now we are going to adjust this knob, and we are going to set same voltage as well as current similar to the first plate. So same 120 as well as 0.54. So remember, same power we are going to give to the black plate as well as test plate. Now see the temperature readings. So first of all, see the thermocouples. So 1, 2, 3 are mounted on the test plate. Next, 5, 6, 7 are mounted on the black plate, and then another thermocouple mounted inside the chamber. So to measure the chamber temperature, right? So 1, 2, 3 indicates the test plate temperatures. Next, 5, 6, 7 indicates the black plate temperatures. T4 indicates the chamber temperature. So the temperature inside this enclosure. So now we need to wait until the system reaches to the steady state, right? How can we know that whether it has reached to the steady state or not? So we are going to observe this temperature reading. So now see, it is 236. So wait for 5 minutes or wait for 10 minutes and observe the temperature. If it is constant, if it is again 236, then it has reached to the steady state. Suppose if it is changed, and again wait for 10 more minutes and observe the temperature reading, right? So we should wait until the system reaches to the steady state. So in this lab, this will take approximately 1 hour or 45 minutes to reach to the steady state. So now the system has reached to the steady state. So I already given the power to the both plates. So the system has approximately reached to the steady state. So 237 degrees. So it is taking much time to change this temperature. Okay. So now the system has reached to the steady state. So now we can note down the temperatures. 1, 2. So T1 temperature is 237. T2 temperature is 234, and T3 temperature is 231. So these are the test plate temperatures. Next, T4 is the chamber temperature. So it is 192 degrees centigrade. Next, T5. So it is 189. T6 is 190. T7 it is 69 degrees centigrade. So these are the black plate temperatures. So we are going to take the average of these 1, 2, 3. Average gives us the average temperature of the test plate. 5, 6, 7 average gives us the average temperature of the black plate. And we are going to use the equation epsilon P is equal to epsilon b T b power 4 minus Tc power 4 by Tp power 4 minus Tc power 4. So this gives us the emissivity. So note down the emissivity value will always less than 1. So it lies in between 0 and 1. So another important point I would like to tell you is, so here you can see, so one temperature or two or three, it is around 230 degrees centigrade. If you observe 5, 6, 7, so it is around 190. Nothing but test plate temperatures are high and black plate temperatures are less. So this is because, so the black body, so already we had seen in the introduction. So the black body is a perfect absorber as well as an emitter. So whatever the radiation that is going to absorb by the black body, it is going to be emitted. So because of that, this test plate absorbs all the radiation is coming from the black body. So the temperature of this test plate will be high. Okay. So this is how we are going to calculate the emissivity of the test plate by taking the reference of a black plate.